Okay, let's go ahead and go over a couple of problems on how to solve exponential and or logarithmic equations. We will learn several methods of solving certain equations based on the nature of the equation itself. However, today on this video, I'm going to focus on the definition or the relation between the log and the exponential equation. So we can go, if it's exponential, we can switch to log and then solve. If it's a logarithmic equation, we may change it, or we may write the equivalent exponential equation and then we solve. So we'll use this technique just for this piece of the video. Later on, we'll attempt other techniques of solving either exponential equations or logarithmic equations. But for now, we are going to go over the definition of each of the functions. First of all, let's just do a quick recall. If I have f of x equals a b to the x, assuming that the base is bigger than 1, and just for easiness, let's assume that a equals to 1. So this will be the exponential function. Important to recognize the domain of the exponential function is all real numbers. Domain of the exponential, all real numbers. What about the logarithmic equation? We have f of x equals log base b of x. The domain is all positive numbers. Okay, so the domain, the log, is only defined from 0 exclusive to the positive world, whereas the exponential function can take anything. So when we are solving equations, once we get the answer for the exponential, we should always verify. However, we should not be that concerned because the exponential takes anything. The domain is all real numbers. However, when we solve logarithmic equations, we have to make sure that we do not violate the domain restriction. Namely, the log can only take positive number as its argument. Okay, I cannot find the log base whatever of -10. The log doesn't understand negative number, does not understand 0. So this is what I wanted to do, this quick recall, just to always keep in mind that as we solve equations, we must make sure we do not violate the domain issue of the log. The exponential, I repeat, anything goes. So let's go ahead and go over a couple of examples. Also, let's go ahead and review the following. As you notice, I will use the same example. 2 raised to the 3 equals 8. So we have two questions. 2 to the 3 equals what? That will be an exponential equation. Or 2 raised to the what equals 8. That will be a logarithmic equation. So same question asked differently. 2 to the what equals 8. That will be a logarithmic equation. Question, I should say, and 2 to the 3 equals what? That will be an exponential question. So base, exponent, output. So in this case is base 2 raised to the 3 equals 8, but I can also think logarithmic way. So log base 2 of 8 equals 3. So 2 raised to what number will give me 8? 2 raised to what number will give me 8? So that's how I switch from log to exponential and vice versa. 2 raised to the 3 equals 8. Okay, so what if I have the following? What if I have the following equation? 10 raised to the 2x plus 3 equals, I don't know, 1, 2, 3. 10 raised to, let's go ahead and do a simple one. First of all, if I have 10 raised to what number will give me 1, 2, 3. Okay? So I have an exponential equation. I need to change to log. Okay, exponential. So first thing, log. Okay, so I'm going from exponential to log. As of course, we know that log base 10 is your common log. So I'm going to put 10 for now, just to verify. So then we put the output. In this case, the output would be 123. and then the log equals the exponent would be x. Okay, so if we try, it would be 10 to the x equals 123. That's exactly what we have. Of course, we don't need the 10 because that's your common logarithm, and then the x. So that's it. So the corresponding equation, logarithmic equation of 10 to the x equals 123 is the same thing as log base 10 of 123 equals x. So in this way, we can solve x equals a number. The calculator will give me the answer, so I'll do it in a few. Now, so this is the basic template. What if you have the following? What if I have 10 raised to the x plus, I don't know, minus 7 equals 123. Before I change to log, I need to get rid of this 7, so we add the 7. So I have 10 to the x equals 123 plus 7 will be 130. Now that I have 10 to the x equals a number by itself, I can switch to log. So it's log base 10 of 130 equals x, and then the calculator will do the rest of the work. Okay. What if I have the following? What if I have 10 raised to the 2x minus 5 equals 98? Okay, same old. We just simply from exponential change to logarithmic. So it would be log base 10 of 98 equals 2x minus 5. Since we need to isolate the x, I must add 5 and divide by 2. So be careful here, folks. When you add 5, it is not going to be log of 98 plus 5, which is log of 103. No, it's going to be log of 98, whatever the number we get from the calculator, then we add 5 equals 2x. Since I'm solving for x, I divide by 2 and eliminate here. Okay, so then it's going to be log of 98, whatever the number is, plus 5 divided by 2 equals x. Okay, last but not least, notice that it's the same thing. If I have, I don't know, 2 times 10 to the 3x minus 5 equals 35. Okay. The first thing we need to do is to add 5. By the way, never ever think this is going to be 2 times 10, that will be 20 raised to the 3x. Absolutely not. This 10 is raised to the 3x. It's just a constant that is multiplied. But anyways, we go ahead and add 5. So that would be 2 times 10 to the 3x. Sometimes you will see a parenthesis. Yeah. So 2 times 10 to the 3x equals, we add 5. So that would be 35 plus 5, that would be 40. And then, of course, before I switch to log, I must have the 10 to the 10 to the number with the variable by itself. So that means that I have to divide by 2. Divide by 2. So now I have 2 over 2 is 1. So now I have 10 to the 3x equals 40 over 2. That would be 20. And now, of course, I can switch to log. Log base 10, which is the common log of 20, equals 3x. Okay, so that would be, I'll write it down with the camera, so that we have what? Log base 10 of 20 equals 3x. Since I'm solving for x, I just simply divide by 3. So x will be log base 10 of 20 over 3. So that's what we have. This to look very sloppy. Okay, so let's go ahead and check these numbers in the calculator just to have an idea. It's going to be longer than I thought. So let's go ahead and try those numbers. I believe you should be able to see the calculator now. We hope so. So the first one was log of 123. We just simply click log of 123. The answer would be, of course, 2.0899 to approximately 2.0899. Is that correct? Well, it was the exponent of 10 that will give me 123 when I raise 10 to that number. So we can always verify 10 raised to the answer that we just got better be 123. Bingo. Second number that we had was same thing, log of 130. So log of 130 equals 2.1139, just approximately. So x is approximately 2.1139. Okay, so what do I have that number? That would be the exponent of 10. So if I go 10 raised to that number, and then I subtract 7 minus 7, better be 123. Voila, 123. The other example was, we need to calculate what? For this one, I'm a little bit lazy. I don't like to put the parentheses galore, so I just go step by step. So I do the log of 98 equals whatever, so that's 1.99. To that number, I add 5 equals blah, and to that number, I divide by 2, enter 3.4956. In that way, I don't have to put a bunch of parentheses. So x equals 3.4956. Okay. Now it's going to be tough to verify, so let's see how can I do that. 10 raised to the parentheses, that will be 2 times the answer, 2 times the answer, minus 5, close parentheses, it better be 98. Perfect. Okay, let me stop sharing. Okay, so hopefully you saw how we punch it in, and that's it. So we got the answers. So we solved 4 exponential equations using the definition of the relationship of log. Let's go ahead and try 3 more examples. So let's solve these 2 problems using the definition of the relationship between exponential and log. Just to recap, it's more of the same. Base 10, so we do, okay, fantastic. It's an exponential, so we switch to log. Log base 10 of equals what? It's always equal, the log is the exponent, so it will be equals to 5x minus 1. The argument is 77, of course the base is 10, which we don't write. And so we just have to find the log of 77 using the calculator. We add 1 equals 5x, and now we divide by 5, and this one by. So that would be the answer for x, log 77 plus 1 over 5 equals x. Now this one, the base is e. So I don't use the common log, namely the log base 10. I use the natural log, which is the log base e. In other words, ln. But first of all, I need to clean it up a little bit. We might want to get rid of this 1. So it will be 2 times e, negative 3x plus 5 equals 7 minus 1, that is 6. We may want to get rid of the 2 as well. So we divide by 2. So now I have e to the negative 3x plus 5 equals 3. Now we are ready to switch to logarithm. Where is the equivalent log equation? That would be log base e. So I'm going to violate the rule just a little bit. So log base e of 3, which is the argument, equals the exponent. So it will be negative 3x plus 5. So we have what? E raised to the 3x minus plus 5 equals 3. But of course, this is a mathematical thing. We never say log base E. We just simply write ln. So that means ln. Okay. So ln of 3 equals this number. Since I'm solving for x, I need to subtract 5. So ln of 3 minus 5. If you want, you can put the parentheses so you don't get tempted to do ln of 3 minus 5. Negative 2. So ln of 3, whatever that is, minus 5 equals negative 3x. And once we get that number, we just simply divide by negative 3. And that will be it. See how straightforward it is to switch to solve exponential equation in this, if we have it in this form, using the definition or using the inverse function, which is of course the logarithmic function. Notice I did not check the answers because we feel comfortable and confident. And what gives you our confidence level? That we know that the domain of the exponential function is all real numbers. So it doesn't matter what number goes in, the exponential function can handle it. It's the tough one, it can process it. The domain of real numbers. Okay, so that's it. I will not do the calculator. I believe we know how to. Well, let me show this one since I have not used ln yet in class as of now. So let's see. Let's go ahead and share the calculator. Okay, so let me turn this thing on. Let me clear. So ln is right here. So ln of 3. This one, I'm just going to close the parentheses. Now, what the heck, I can just do minus 5, enter. So that's the answer, divided by negative 3, enter. So that will be the answer, 1.3000, yeah. So x is approximately positive 1.3005, I think. Yeah, okay. So let's verify this is true. So if I take 2 times second ln will give me e raised to the negative 3 times x. In this case will be the answer that I got, plus 5. I close parentheses and then I do plus 1. It better be 7, if not, I'm in trouble. Voila, that's your 7. Okay. So 2 times e raised to the negative 3 times the answer we got, plus 5, close parentheses, plus 1 equals 7. Perfect. Now let's go ahead and solve, practice solving a couple of logarithmic equations. So I have log base b of x equals y. So I need, how do I switch to exponential? The base, identify the base, raised to the exponent, in this case the number y, equals the argument. This is why when I have log base 3 of 2 equals, oops, I scrolled the video. So anyway, so if I have, for example, log base 3 of 2x plus 1 equals 4. So what do I do? It's going to be a big number. So we do what? 3 raised to the 4 equals 2x plus 1. And I will do it. Okay. So let's see what happens here. So the base is 3. The exponent is 4 equals 2x plus 1. 3 times 3 is 9. 9 times 9 will be 81 equals 2x plus 1. I subtract 1, so I have 80 equals 2x divided by 2. Therefore, x equals 40. Okay. So, of course, I told you that we better verify the log. I know this one we will not have any issues, but let's always check it out. When x equals 40, 2 times 40, 2 times 4 will be 80. 80 plus 1, 81. The important thing is that the number that goes here is positive. Yeah, so we are trying to do log base 2 of 31, which indeed is 4. Okay, so that would be it. Let's try another one. It has several examples. Let's see what we can do here. Log base 3 of 4x minus 7 equals 2. It's going to be very repetitive. So once again, my base 3, the exponent 2 equals the argument here. So 3 raised to the 2 equals 4x minus 7. And 3, this is 9, equals 4x minus 7. We may add 9. 9 plus 7 will be, we might add 7. So 9 plus 7 equals 16 equals 4x. We divide by 4. Therefore, x equals 4. When I plug it in here, 4 times 4 is 16 minus 7, positive number. That's what we want. Remember, the domain of the log function is all positive numbers. So let's try this other one. Okay. Let's try this other one. It's more enough. So log base 2 of equals 3. I have here x plus 7, x minus 7. Yeah. Don't get intimidated, it's more of the same. 2 raised to the 3 equals this. So 2 raised to the 3 equals this argument is x plus 7 over x minus 7. Last time we checked, log 2 to the 3 is 2 times 2 times 2, that would be 8. And now we multiply by the LCD. In our case, the LCD is x minus 7. Cancels here. So what do I have on the left-hand side? I have 8x minus 5, 6 equals x plus 7. I could subtract 1x, 8 minus 1, that will be 7x equals, and I can add 56 to the 7. So that will be 63. I divide by 7, so x equals 9. And we are done. Let's work one more time. The last one, I have log of x squared minus 9x equals 1. Oops, I don't have a base here. Yes, we do. We always have a base. There is an invisible 10 here. So it's 10 raised to the 1 equals the argument. 10 raised to the 1 equals x squared minus 9x. So now we are stuck solving a quadratic equation, so we should equal it to 0. So we have x squared minus 9x minus 10 equals 0. This one factors very nicely. Factors of negative 10, that gives me negative 9. Of course, 10 times 1, from negative 10 times 1. So x minus 10 times x plus 1 equals 0. 0 product. So when x minus 10 equals 0, x equals 10. Yeah. And then when x plus 1 equals 0, x equals negative 1. So we have two potential solutions. Let's see if those solutions work. So when x equals 10, 10 squared will be 100. 9 times 10, that will be 90. 100 minus 90 is positive. So we are safe with the 10. What about negative 1? This we are also safe here. When x equals negative 1 times negative 1, well, not really. Negative 1 times negative 1 will be 1. -1 times -9 will be actually +9, and that, yeah, so that will give me 10. So we are also safe with -1. So this equation will have two solutions, which is perfectly fine. The way it's written as is. And that will be it. Thank you.